Okay guys, so in this video we are going to talk about carboxylic acids and everything that's in the A2 syllabus, A2 organic chemistry related to carboxylic acids. Okay, so the first thing that we need to do is the acidity of carboxylic acids and the comparison of acidity with phenols and alcohols. Okay guys, so basically carboxylic acids are weak acids. The first point to note over here is that they are all weak acids, and weak acid is any acid that partially ionizes in aqueous solution. An acid that partially ionizes in aqueous solution. For example, we have ethanoic acid CH3COOH aqueous. If it is added to an aqueous solution, the ethanoic acid dissociates to release H positive ions, which are also aqueous, and ethanoate ion CH3COO negative, which is also aqueous. Okay, so this is basically carboxylic acid. The second carboxylic acid, basically of the carboxylic acid family, the two carbon acid, ethanoic acid. Okay, this is a weak acid, so its dissociation is shown by a reversible arrow, and it partially ionizes an aqueous solution. Not all of the acid molecules would have ionized to produce these two products, but rather partial ionization takes place in this compound. Okay, now let's compare the relative acidities of carboxylic acids. RCOOH is a general formula. Carboxylic acids with phenol. Okay, so to compare the relative acidities of these three compounds with carboxylic acids. Okay, so basically I'll give you the relationship. I'll give you the relative acidities of the three compounds. Carboxylic acids are the strongest of the three acids. I'm using the word strongest. All the carboxylic acids are weak acids, but in comparison to phenol and ethanol, carboxylic acids are stronger, and then phenol is stronger as compared to ethanol. Okay, so this is basically the uh, re- general form, or basically you can say that the general acidity of the three compounds. And basically this relation is almost always asked for at least 1 mark. So this is an important relationship. Okay, I've seen many questions in the P4 paper, especially on the relative acidities of the three. Okay, now let's explain why this is so. Okay, in order to explain this, we'll need to go in a bit more detail into the structure of and the ionization of the carboxylic acid. I'm taking ethanoic acid as an example. If it dissociates in aqueous solution, it produces ethanoate ion, CH3COO negative ion, and H positive ion. This ethanoate ion over here is our conjugate base, and the ethanoic acid is our acid. Okay, now always remember one thing. The if this base, there is a general relationship. The stable the base, the stronger the acid. So the greater the stability of the base, the greater the stability of this conjugate base, comma, the stronger the acid. So now let's see what makes this base stronger as compared to the phenoxide ion and the ethanoate ion. And the ethoxide ion of ethanol. Now, if we draw display this C double bond O and O negative ion, oxygen has its lone pair of electrons. Okay, now in this case, the oxygen uses one of its electron pairs and donates it oxygen, since has lone pairs, it can donate the excess electrons to the bond that joins it to the carbon atom. As a result, what happens is that carbon oxygen double bond starts forming, and once this bond starts forming, the carbon is tetravalent. That is, it can at the same time have a maximum of 4 electrons. This is the fifth bond that is trying to form. So at the same time, the electrons of this bond, this carbon-carbon double bond, the pi bond electrons, they are transferred to the oxygen atom right next to the carbon atom. Okay, so once the pi electrons are transferred to the oxygen atom, this bond becomes a single bond and the negative charge comes over the oxygen on the upper side. So this forms a structure. O negative comes over here. The negative charge has moved from the oxygen on the right to oxygen on top. So the negative charge has came on top, and basically a single bond forms and a double bond comes over here, and the remaining structure stays the same. This is the phenomena that basically stabilizes this base. Okay, now this is the ethanoate ion. It is stabilized because this negative ion, this negative charge. Now, how to put this answer into words? It's basically quite simple. Uh, the negative charge, it gets distributed. The negative charge is distributed in between the two oxygen atoms. In between the two oxygen atoms, this means that the charge has spread. So charge has spread, and spreading of charge, it stabilizes the base. Spreading of charge stabilizes the base. And why does this stabilize the base? That's because stabilizes the base. That's because if this charge spreads out, the magnitude of the charge that is concentrated on the oxygen atom, the magnitude of this negative charge that is concentrated on only one oxygen atom, it decreases, and it basically kind of spreads out in between the two oxygen atoms. And since the charge spreads out in between the two oxygen atoms, and this phenomena of spreading of charge is basically what's known as resonance. Yes, it's the same resonance that occurs in benzene. In the case of benzene, we have three pi bonds, right? So the three pi bonds, they keep on resonating around the benzene ring. They keep on changing here and there. So that's why it forms resonance hybrids. So these are the two resonance structures of carboxylic acid group. Basically the base of the carboxylic acid. And then again, this oxygen can donate its electrons back to the carbon oxygen bond, and again these electrons are transferred back to the previous oxygen atom. So basically the negative charge does not stay at one position, but rather keeps on shifting from one oxygen to the other. Okay, so this basically spreads the charge, and the spreading of charge stabilizes the base, and the stable the base, the stronger the acid. And that's because more stable base is less likely to accept this proton back, and if it is less likely to accept the proton, then it is less likely to shift backwards. It is less likely to form the undissociated acid again. So the acid stays in the dissociated form, and the more the acid is dissociated, the stronger the acid. Okay, so now what to include in your answer? Okay, so the points that you must include in your answers while explaining the stability, while explaining the greater acidity of carboxylic acids, is that the ethanoic first mark that you'll get is on the first statement that I just uh, over here, this statement that carboxylic acid is stronger than phenol, and phenol is stronger than ethanol. Okay, so this is one mark, and then the remaining marks are for the explanation. Okay, so the next mark that you guys will get is that is on the basis of explaining the resonance in the ethanoate ion. So basically, you are going to say that the negative charge spreads in between, or rather than saying in between, it spreads over the two electronegative oxygen atoms. Okay, the negative charge spreads over the two electronegative oxygen atoms, and then this spreading of charge stabilizes the ethanoate ion, the CH3COO negative ion, and since it stabilizes the ion, this makes the acid a stronger acid. Or you can also write it as an additional valid point that the oxygen hydrogen bond in the ethanoic acid, it is more easily broken uh, in the carboxylic acid as compared to the OH bond in the phenol and alcohol. So let me write down the general formula of alcohol. Okay, so these are the basically the points, and the comparison usually comes for 3 marks. Well, they may give you a comparison marks as well, but it's simple. Generally, it's this comparison is asked for 2 to 3 marks, but it is asked. So uh, remember these points very carefully. Try to go over a few marking schemes in the past papers because the keywords that are used in the marking schemes are important, and you guys must use the marking scheme keywords. Okay, guys. So see you in the next video on the effects of substituents on the acidity of carboxylic acid.